Hello everyone and welcome to our webinar on data migration on-prem to Snowflake. My name is Hassan Sherwani and let me introduce you with my team. My name is Hassan. I'm working as a practice head for data analytics. I have around 14 years of experience in this domain. And with me, I have Farooq Gill, who is technical lead, and Ikra Anwar, who is data engineer. Over to you, Farooq.
Hello everyone, my name is Farooq Gill. I'm technical lead at Royal Cyber. I have over 14 years of experience in data engineering and data science.
Ikra, would you like to go ahead?
Yeah, thank you, Hassan. Hello, everyone. I'm Ikra Anwar, a data engineer with 4 years of experience in the field. Throughout my career, I have had the opportunity to immerse myself in a various aspects of data engineering, from designing robust data pipelines to optimizing systems for performance and scalability. Thank you, everyone, for joining. Over to you, Hassan.
Thank you, Ikra. So moving forward, let's talk about our agenda. First up, we will talk about Royal Cyber. What is it about? What we do? Then we would talk about ecosystem of Snowflake. So it's a fascinating technology, but some parts of it are missing. We would talk about a very specific problem that is data migration from your on-prem to Snowflake. And we would use a case study which is in banking and financial domain. Afterwards, Ikra would walk you through our demo. And finally, we'll discuss about lesson learned. At the end of it, we would have question and answers, and we hope that you would contribute more into it. Starting for Royal Cyber, we are a very mature organization, around 20 years in consulting business. We have our locations around the globe. Head office is in Naperville, but we have presence in Middle East, also in Asia, and in offshore, we have offices in Pakistan and India as well. We really believe in excellence, and for that reason, we have around 250 plus certified consultant, including Snowflake. We have our partners. Microsoft is our gold partner. Other partners are Oracle, SAP, and Salesforce. And of course, Snowflake and Databricks are leading partners in data science and data analytics. So let's talk about our data analytics practice. At Royal Cyber, we work in four key streams. Number one is data engineering. This is where we talk about our process automation, data strategy, security, data warehouse, and ETLs. Afterwards, we have machine learning solution. In machine learning solution, we talk about data pre-processing, we talk about feature engineering, model development, model selection, hyperparameter tuning, in generative AI, it's a modern and new domain where we talk with different type of a data, which is text data, image data, could be in form of videos or audios, more like unstructured data. And with recent boom of ChatGPT, this domain is gaining a lot of hype. Finally, we have MLOps, what happens when our model would go into production, how to take care of them, some concepts like data drift, concept drift, or model drift, how to take care of all those aspects is actually part of these practices. So all these streams are actually part of one whole giant data analytics practice. And in this webinar, we will be actually focusing on data engineering solutions. We have other webinars. You can go on our website to give it a look on Gen AI, machine learning, and MLOps. But let's talk about data engineering solution. With that, now I give it to Farooq for our main problem statement, starting for our data migration. So over to you, Farooq.
Thank you, Hassan. The more complex a business is, the more sophisticated its data architecture becomes, and we know that the banking and financial services sector is one of the most tangled industries from the data management perspective. Banking institutions currently store all this data on-premises in traditional databases, which are facing limitations in scalability, performance, and agility. This on-premises infrastructure is costly to maintain and manage, and it hinders ability to keep pace with evolving data demands and regulations. Also lack the ability of effectiveness analyze our vast amount of data for actionable insights to improve customer experience optimize operations, and mitigate risks. What are the key business advantages offered by Snowflake? First of all, we have cost reduction. In an on-prem environment, organizations bear the upfront cost of hardware, maintenance, and upgrades. In contrast, Snowflake's cloud-based platform offered a pay-as-you-go model, eliminating capital expenditures, providing scalability, and potentially reducing overall costs. Additionally, Snowflake's managed services can lead to operational efficiencies, allowing teams to focus on analytics rather than the infrastructure management. The next advantage is scalability. Snowflake is highly scalable compared to on-premises databases due to its cloud-based architecture. It allows users to scale compute and storage resources independently, accommodating varying workloads. This elasticity ensures efficient resource utilization, eliminating the need for upfront hardware investments and enabling seamless scalability based on demands. The next main advantage is high availability. Snowflake offers high availability through its cloud infrastructure, ensuring data redundancy and automatic failover for seamless operations. This contrasts with on-prem databases where achieving high availability often requires complex configuration, redundant hardware, and manual intervention, making Snowflake a more resilient and user-friendly option. So let's talk about the salient features of Snowflake. First of all, we have automatic performance optimization. Snowflake offers automatic performance optimization through its cloud-native architecture. It leverages features like automatic clustering, metadata-aware storage, and query optimization to enhance performance without manual intervention. This allows users to focus on analytics rather than fine-tuning, ensuring efficient and optimized operations. Next is data integration. Snowflake supports seamless data integration through various methods, including native connectors, Snowpipe for real-time data loading, and partnership with popular ETL and ELT tools. Its cloud-based platform simplifies data integration, offering scalability and flexibility to handle diverse data sources efficiently. Snowflake's architecture promotes a unified approach to data integration and analytics, streamlining workflows for improved productivity. The next salient feature is data sharing. Snowflake allows sharing through its secure, governed, and scalable platform. Users can share data seamlessly across multiple Snowflake accounts, regions, and cloud while maintaining full control over access permissions and data security. With Snowflake's architecture, organizations can easily collaborate, exchange data, and drive insights without the complexities of traditional data sharing methods. Next, we have cost management. Snowflake provides cost management through its pay-as-you-go model, allowing users to scale resources based on demand and avoid upfront infrastructure investments. Features like autopause for compute resources during inactivity, resource monitor, and reserve capacity options assist in optimizing costs. Users can also leverage detailed usage and cost report for monitoring and adjusting resource allocation to ensure efficient and cost-effective operations. Here we have the high-level solution architecture diagram. Data from on-prem database like SQL Server, Oracle, Postgres, or MySQL is first transferred to cloud storage. The cloud storage can be Amazon S3, Azure Blob, or Google Cloud Platform. An external stage is then created on cloud storage, serving as a landing zone for the data. Using Snowpipe or continuous data ingestion service in Snowflake, Data is seamlessly and automatically loaded from external stage into Snowflake data warehouse, ensuring real-time or almost real-time updates in the Snowflake database. This streamlined process optimizes data storage, scalability, and analytic capabilities. Let's explore the significant outcomes that Snowflake brings to the table. Number one, improved scalability, performance, and agility to handle growing data volumes and complex analytics. Number two, enhanced data accessibility and collaboration for faster and more informed decision making. Number three, reduce data storage and management costs through the elimination of on-premises infrastructure. Number four, improve data security and compliance through Snowflake's robust security features and governance capabilities. And number five, reduce the burden of managing and maintaining on-premises infrastructure. Here is a high-level architecture diagram of Snowflake. On top of we have Snowflake Cloud Services layer, which manages metadata orchestrations and resource allocation. It includes components such as infrastructure manager, optimizer, metadata manager, and security. And below the cloud services, we have query processing layer. The query processing layer in Snowflake handles SQL queries and comprises components like the query dispatcher, optimizer, and execution engines. It ensures efficient and parallelized query execution, delivering high performance for analytical workloads. At the bottom, we have database storage layer. Snowflake's database storage layer stores data in a unique multi-clustered object storage architecture, and this layer utilizes cloud-based storage services, allowing scalable and elastic storage capacity while maintaining a separation of compute and storage resources for optimal flexibility and performance. As we reflect on the evolution of our database operations, it's essential to recognize the distinctive phases that have shaped our approach to data management. In the earlier phase, database operation practices were characterized by business operations heavily reliant on manual Excel-driven processes and on-premises systems. The landscape was marked by lack of automation, resulting in time-consuming and resource-intensive database management. In the current landscape, database operation practices grapple with challenges stemming from disparate business systems, leading to siloed data and decision-making process. To address this, there is a notable shift towards integrating databases, leveraging cloud solutions, and adopting collaborative approaches to enhance data cohesion and streamline decision-making across organizational units. Looking ahead, the future of database operations is set to bring about a new era of data-driven strategic planning. Automation, AI-driven analytics, and advanced decision support tools will empower organizations to make quicker and more accurate decisions. This evolution promises to unlock operating leverage, enabling businesses to optimize resources, enhance efficiency, and stay agile in the increasingly dynamic and competitive landscape. Here are some cloud differentiators for banking sectors. In the domain of Snowflake, we experience unprecedented performance and scalability. With a unique architecture, there is no resource contention with other departments, ensuring dedicated and optimized resources. This translates the constantly fast queuing processing, even during the critical moments, empowering seamless and efficient data analysis for timely decision making. In Snowflake, security and governance are paramount, offering fine-tuned controlled our read-write privileges to adhere SOX automation requirements. Additionally, advanced data masking capabilities provide a robust solutions for sharing sensitive data, ensuring comprehensive protection and compliance. Snowflake's secure and governed environment establishes a foundation of trust and integrity for managing critical financial and sensitive information. Next, we have centralized source of truth. Snowflake serves as our centralized source of truth, consolidating all business systems under a single unified data platform. This integration provides a holistic 360-degree view of our business, enabling seamless cross-functional insights and empowering data-driven decision-making. Snowflake's centralized architecture ensures consistency and accuracy, fostering a comprehensive understanding of our organization landscape. Next banking differentiator is automation. With Snowflake automation capabilities, we have streamlined operations by automating key metrics that once required substantial manpower. This efficiency not only reduces operational overhead but also enables faster decision-making with automated KPIs. Snowflake's automation empowers us to focus on strategic initiatives, leveraging real-time insights for swift and informed decision-making in our dynamic business environment. On the next slide, we have banking insights, that how Snowflake can be used in banking sector for the historical, real-time, and the predictive analysis. As far as the historical dashboarding is concerned in banking sector, Snowflake enhances historical dashboarding by consolidating and visualizing past financial performance metrics. Through a centralized data platform, comprehensive historical insights into customer transactions, market trends, and risk indicators are readily available. This empowers banking professionals to make strategic decisions based upon deep understanding of historical data. For real-time data in banking, Snowflake becomes a crucial tool for anomaly detection by continuously monitoring transactions, user behaviors, and market data. Snowflake helps identify unusual patterns or activities in real time. This enables this enables promote detection of fraudulent activities, ensures regulatory compliance, and enhance overall security measure within banking ecosystem. In banking sector, Snowflake's predictive analytics proves valuable for optimizing spending and resource allocation. Predictive models within Snowflake can forecast future customer demands, enabling banks to strategically allocate resources, personalize services, and optimize standard purchase decisions and reverse instance strategies. This, this predictive approach aids in cost management and enhances the overall efficiency of banking operations. Now I pass control to Ikra, who will conduct a live demonstration for you. So over to you, Ikra.
Thank you, Farooq, for providing such an in-depth details of how the banking sector can progress through migrating data from on-prem to cloud. Your insights were truly enlightening. I'm thrilled to present you something that promises data migration with security. So we are using Snowpipe for continuous data ingestion into Snowflake's cloud data warehouse. Snowpipe is a strategy that is specifically designed for micro-batching. So using Snowpipe, we can ingest a few files in a day or millions of files in a minute into a data warehouse. Snowpipe provides lightweight and scalable service to ingest any amount of data securely into Snowflake. In order to migrate the data from SQL Server to Snowflake Cloud, we will export the banking data and save it into a local system. And then we are going to use the data to load into Snowflake's cloud data warehouse using Snowpipe. Next, we are going to look at AWS side of configuration to create and facilitate the Snowpipe. And finally, we will look at the data we loaded into Snowflake using Snowpipe. So let's first export the data that is available in SQL Server. This step involves extracting the desired data from database depending on the specific requirements. This could also involve querying a specific table, filtering data based on certain criteria. Since I want the entire banking data to be securely available on cloud, I would export the whole database having banking transactions. But before initiating the data export and migration process, it's essential to review the data within the SQL Server environment. It ensures that the data being exported is accurate, up to date, and meets the required criteria for migration into Snowflake. So let's have a look at the banking data. And here we go. So our data is comprising of 16 crucial columns. First we have unique ID of every customer, then we have transaction ID, account ID, transaction type, transaction amount, then we have account balance and symbol associated with the transaction, and the end we have full date and time of the transaction. And now that we have reviewed the data, we can export it in any format that we want. So let's export the database. And for that, first I'll click on database, and here I can find the option of task, and within that we have option to export the data. So I'm going to click on export data, and we can see a tab showing welcome to SQL Server import and export. I'm going to click on next, and here we have to provide the data source. So I'm going to go with SQL Server Native Client 11.0. Click next. And now we need the destination for our data. So I'm gonna go with flat file destinations, and after this I'll have to give the path of the destination and provide a name to the file. So I'm gonna go with this. Now I can browse the destination for my data, and here I have copied the destination. I'll paste it here, and now I have to provide a name to the file that will hold this entire banking transaction data. So I'll say it is bank migration transactions. Click next, 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 and finish. Now the data that is available in the database is being copied into our local system. And we don't see any error and warnings for now. Now the data is totally copied into our local system. So I'm gonna close this. Now the data is stored locally on machine, and it is readily accessible for further transfer and migration. We can send this exported data into S3 bucket, and from there, using Snowpipe, we can securely and seamlessly get the data into Snowflake database. But before that, let's do the configurations that are required in Snowflake and AWS. So in case of AWS, first we have to create an S3 bucket, which will act as staging area to store all our data files. And here we have to provide the name to our bucket. So I'm going to name it Snowflake Data Migration, and simply we have to click on create bucket. So here is our bucket that we have just created, and this is where I'll be uploading banking transaction data files. Then we have to create a role, and for that we need to go to the AIM, and we can simply go into the roles and create a role. Click on AWS account. For role we have to provide a valid name to our role, and I'll be providing it the Snowflake data migration again, and simply click on create role. So Snowflake data migration role is created. We will use the role later on after setting up configurations in Snowflake. Now let's go to Snowflake to have a look at the Snowflake part of configurations and Snowpipe creation. So first of all, I have created a database and a schema. And now I'm creating a table. The table must be having the same columns that are in our data that we exported earlier from SQL Server. Since we have already had a look at the data before exporting it, so we know these are the columns in the data. So let's create the table. So our table is successfully created. And next we have to create a file format. And when we were exporting the data, we saved the data in CSV format. That's why I'm creating CSV file format here. So let's create it. And now we have to create storage integration. And for that, the role I created in AWS, I need the storage ARN from there. And here it is. And we would also need specific location where we will be uploading the files. So remember the bucket we created and provided it a name. That is the path to the location. Let's create the integration. So our integration is successfully created. Here I'm creating an external stage. It will basically stage the files before loading the data into any table. And I'll be using this stage while creating the Snowpipe to copy the data from stage into the destination table. So here I would need the path to the storage bucket, S3 bucket, and the storage integration name which I've just created, and the file format. So I have all other information. I would just paste the URL of S3 bucket and create the external stage. Now let's check the available stages. So we have one stage which is AWS CSV folder. Now let's describe it. And here we can find all the details associated with this stage. Let's list the stage now to see if we have any files into it. So we don't have any file in our stage. So let's move ahead to the next step to create a Snowpipe, and here we are creating the Snowpipe which dumps the data into our table from external stage that we just created. So let's create it. So our Snowpipe is successfully created. After creating the pipe, let's check the description of the pipe, and here we can find all the details related to the pipe. In the details here, we can find a notification channel which we will use to create event inside our S3 bucket. So this event notification is to trigger the Snowpipe execution, and if any new file is loaded in the bucket, the file will be staged into the external stage, and the data in the file will be seamlessly ingested into table within seconds. So I'll copy the notification channel and let's create the event notification. As I said, we will be creating it inside the S3 bucket. So this is the bucket I've created earlier. Going into the properties, and here we can find an option for creating an event notification. And we have to provide it a name. So let's name it notify data migration. And from here we have to click on all object script events. And from here we have to go with SQ. And now we have to specify the SQ. Since we have ARN, so we will click on SQ ARN. And let's just copy this ARN and paste it here. Our event notification configuration is successfully completed. Now that all the configurations are completed and we have a fully secure, scalable, serverless data pipeline built between AWS and Snowflake. So let's upload the exported data into S3 bucket and see how seamlessly millions of rows are loaded into Snowflake database. Now we are going to upload the exported data into S3 bucket and add file. And here is that file that we will upload, and then click on upload. So this file is going to take some time since it has millions of rows, so bear it with me. But again, depending on internet, it would maybe take like seconds to get uploaded into S3 bucket. Since that is being loaded, let's have a look at our stage, if it has any files or not. And you can see there are no any files into our stage. So our file is uploaded successfully. Now let's have a look at the table. So there are no any data points. Now let's check if Snowpipe is up and running or not. So the details here show that pipe is up and running and the file we have loaded in S3 bucket is sent. Now let's list the stage to have a look at the available files in the stage. So this is our stage, and the file that we uploaded in S3 bucket is now in staging area. And from here, Snowpipe will ingest the data in the transaction table. Let's check the table now. And here we go. So you can see the data is securely loaded into the table within seconds. And this is how Snowpipe allows for near real-time data ingestion into Snowflake. It automatically scales to handle varying data loads, whether you are migrating a small dataset or dealing with large volumes of data. Snowpipe is intelligent enough to handle the loads efficiently. It ensures smooth and continuous data ingestion without manual intervention. Now, I'll hand over the mic to Farooq for lesson learned. Over to you, Farooq.
Thanks, Ikra, for showing us how it's done. Now let's consider into the key insights gained from migrating SQL Server database into Snowflake. To initialize the migration, the initial step involves exporting data from on-prem database. This task can be accomplished using either SSIS or BCP utility. Both of these are provided by Microsoft. However, as we proceeded with the data migration, it became evident that the BCP utility significantly outperformed SSIS packages, especially when dealing with huge data volumes. This was particularly notable that exporting tables with sizes measured in gigabytes. When generating a script to create a table in SQL Server, we typically include the if exists keyword to check for table's existence. However, in Snowflake, this keyword is not spotted. Instead, Snowflake uses the create or replace table statement. It is crucial to ensure that the table does not already exist in Snowflake because the create or the replace table command will overwrite any existing table and the data will be deleted. There are several challenges while syntax migration. In SQL Server, the top keyword is used to fetch the specified number of rows. However, in Snowflake, the limit keyword is used to perform the same task. Likewise, in SQL Server, the bit data type is used for storing 0 or 1. In contrast, in Snowflake, the equivalent for the bit data type is Boolean. Likewise, in SQL Server, we have nvarchar data type, which is not present in Snowflake. Instead, we have varchar data type in Snowflake. So all the nvarchar SQL Server data types must be converted to varchar data types in Snowflake. In SQL Server, if a column name contains a space, it is enclosed in square brackets. However, in Snowflake, the column name needs to be enclosed in the double quotation marks. So this is another difference of syntax between Snowflake and SQL Server. Moving forward, in SQL Server, to store the date and time, we have the data type with the name date time data type. However, in Snowflake, we have timestamp underscore NTZ data type to store the date and time. Next, we have code syntax changes. In SQL Server, for the concatenation, we use plus symbol to concatenate two strings. However, this functionality is performed by the double bar sign in Snowflake. Both SQL Server and Snowflake contains functions, which are commonly known as UDF, user-defined functions. However, in SQL Server, you can only write functions in SQL, whereas Snowflake supports SQL, JavaScript, Scala, and Python to write these functions. Next, we have some database feature differences between Snowflake and SQL Server. First of all, there are triggers in SQL Server which are not supported in Snowflake. However, this functionality can be simulated by using streams and tasks in Snowflake. In SQL Server, we have views which can be used to update database records. However, in Snowflake, we can't use views to update database records. And finally, we have store procedures. Store procedures are present both in SQL Server and Snowflake. In SQL Server, these store procedure can only be written in SQL, whereas in Snowflake, we can use multiple options to write these store procedures like JavaScript, Python, Scala, and SnowSQL. Thanks for being part of our webinar. And now it's time to hear from you. Feel free to ask any questions.